Hi guys, welcome back. Welcome. Thank you very much for staying with us. I am Sibusiso and we are still continuing with our differential calculus. I hope you guys are still learning a lot from Julian and Philippa. We're giving you nothing else but quality content. We hope this is actually assisting you with your calculus. Remember to keep sending us your questions, but we actually have a lot of questions on calculus. You can now start sending us your analytical geometry questions, which is what we will be looking at the week after next. But that doesn't mean that you won't learn anything if you're watching. Just keep watching. You will basically benefit a lot from what we are doing. We're now going to continue with our calculus. We go into a question that was sent to us by Denolan. Let's go and check out what he had to say.
Hi Tenfold, my name is Denolan. Can you please assist me with this question?
Right. Thank you very much for that question, Denolan. It's a very simple question. It's important for you guys to understand that your calculus, so differential calculus in your exam, grade 12s, is actually separated into three sections. There's one part that is asking you to work with rules of differentiation, and then there's going to be the cubic graph, which is what Philippa was working on. And then after the graphs, you're going to get a section that is talking about maximization and optimization, which is applications of differential calculus. So this question that we are currently dealing with is one that is focusing on the first part, which is the actual part that deals with calculus. We're asking you to find the derivative using either first principle or the power rule. Now, it's very important for us to firstly discuss notation because I think I remember a year or 2 years back, people got a lot of challenges in terms of getting marks because they were not using their notation correctly. So that's one of the things that you guys need to take very serious. The notation, if we are using y, you need to use dy over dx when you're deriving. If we're using d of x, you need to do the proper thing. And if it's f, then you lose f prime of x when you're doing your derivative. So let's go and see what this question actually says to us. It says, determine d of x, right? That part there simply means we're asking you to work out the derivative. So we actually want you to find the derivative. You have to find the derivative. You've got to differentiate here, right? Okay, fine, of the function x plus 1 into 3x minus 7. Now remember what I said. If we give you y as a particular function, when you derive, you must say dy all over dx when you are doing your derivative. And secondly, if we say to you f of x equals to something, when you are deriving, you'll have to firstly say f prime of x, which is indication that you are now finding the derivative of the function that we are working with. But if we say just dx like this, if I just say dx and I put my function inside a bracket like that, we won't have anything else except going straight to the answer once you have found the derivative. Now, it's very important for you to understand that for us to be able to find the derivative, we need to change all our terms. All the terms must be in the form coefficient base exponent. Coefficient base exponent, so that we can be able to apply the power rule, which is a very simple rule that says take the exponent, multiply by the coefficient, and subtract 1 from the exponent. Let's see what will happen in this question. So our question is not yet in the form that we need, the form coefficient base exponent. So I'm gonna first of all try to attempt and change it into that. So we've got d of x equals to, if I multiply out on those brackets, x times 3x there is going to give me 3x squared, and then x multiplied by minus 7 will come out as minus 7x. If you multiply 1 and 3x, that will give you positive 3x, and when you multiply 1 and 7, it will simply be minus 7. So quickly, let's clean up there in the middle of the bracket. We've got 3x squared, which doesn't have a friend, aka like terms. Minus 7x plus 3x is basically minus 4x minus 7. Okay, cool. So now we have our function in the form coefficient base exponent. We are ready to start applying our power rule. Let's see what the power rule says. The power rule simply says if you've got a function, right, which is y equals to some coefficient x to whatever the exponent you could be dealing with, the derivative or dy over dx will simply be the exponent multiplied by the coefficient. So you're going to multiply those two, which will be n multiplied by a x to the power. From the exponent, we just need to subtract 1. So I'm going to use that and try to see how is that going to help us work out the derivative of what we're dealing with right now. So if I derive, because we did say that This one, you don't have anything else to write except going straight to the answer. The derivative will just be 2 times 3, which gives us 6x. 2 minus 1 on the exponent will just become a 1. And then a 1 on the exponent of x there multiplied by minus 4 will simply be minus 4 x to the power 0, which will eventually disappear. And the derivative of a constant is actually equal to 0. Now, a lot of people always ask, why is the derivative of a constant equal 0? You can first of all use the first principle to figure it out. However, just look at that minus 7x, minus 7. Minus 7 is as good as, if I just create space there, it's as good as minus 7 multiplied by 1, which you can imagine as minus 7x to the power 0, because anything to the power 0 is actually equal 1, except, of course, 0 to the power 0. So if you derive that exponent applying the power rule times coefficient will be 0 times 7, which will become 0, x to the power 0 minus 1 will give you negative 1. However, if you look at that, anything multiplied by 0 is simply going to become 0. That is why the derivative of a constant is always 0. It's very simple for you to think about it, and the power rule does actually also explain why the derivative of a constant becomes 0. Let's go to the second part of this question and see what is going on there. The second part says, it's a very different notation from the one we were dealing with in the first question. This one says, we have to find dy over dx if y is equals to the square root of x to the power 3 minus 5 over x plus 1 over 2 pi. All right, so like I said in the first example, it's important for you to understand the power rule requires coefficient, base, exponent. So any term that is given to you needs to be changed to that format. If it is not in that format, then it's not going to be easy for you to apply your power rule. And there's something very interesting that the examiner included here, pi. If you don't know what pi is, you might make a mistake and think that it is actually the same as x. It is not. Pi is a constant, so the last term, the half pi, is actually not a term that has got the variable x, but is indeed a constant. So let's see what will happen if we try to fix this so that we make it ready for differentiation. The other thing that is important to keep in mind is this. You cannot differentiate in parts. If one part is ready for differentiation and the other parts are not, you need to fix all of them and make sure every term is ready for differentiation, and then you can be able to derive there. If other parts are not ready, you can't derive those ones that are ready. You must fix everybody. When everyone is ready, then derive at the same time instead of doing it in parts. Okay, cool. So let's see what will happen here. Right, y, which is what we are dealing with here, is basically equal to the cube root, the square root of x to the power 3 can basically be changed. It's actually a set. It is x to the power of 3 over 2, and the other one is minus 5 over x. Now that part there, the second term, we need to actually change this and express it as 5x to the power something. This is x to the power 1. When it goes up, it will become x to the power of negative 1. And then plus 1 over 2 with a pi. Now we are ready to find the derivative. Let's find the derivative. So dy all over dx is equal to 3 over 2 multiplied by the coefficient 1 there will become 3 over 2, x to the power 3 over 2 minus 1. Remember, you must always subtract 1 from the exponent to find the new exponent. So 3 halves minus 1 will just become 1 half. And then negative times negative here will come out as positive 5. X to the power minus 1 is going to become minus 2. This is another popular mistake that people make. Remember, you are subtracting 1 from whatever the exponent we gave you. And here, there goes another term, which is a constant. This is a constant. It's not half x. It's half times pi, which becomes a constant. And when you derive a constant, the answer will just simply become a 0, which we actually never write. So a lot of examiners will sometimes ask you to express your answer with a positive exponent. Now, if you look at this last term here, it is basically x to the power minus 2. We want to fix that. So you'll basically sit with 3 over 2, x to the power 1 over 2 plus. Now, for me to take this and make it a positive, remember from your laws of exponents, when you've got 1 over x to the power n, you can express it as x to the power minus n. So if I also have a negative exponent, I can basically take it under the coefficient that we're dealing with so that the exponent becomes a positive. So this will be 5 over x to the power of 2. Now, if you want to prove to people that you know what you're talking about, you can convert this x square root x here, x to the power 1 over 2 and write it as 3 over 2 multiplied by the square root of x, which is not necessarily important. No one will penalize you for not doing this. I'm just doing it to explain to you that x to the power 1 over 2 can also be expressed as the square root of x. A very nice question indeed. It actually helps us to understand how do you apply yourself when you have to do differentiation using the power rule. There are other rules that you can apply, but the one of power rule is always one that works all the time, particularly if you are in grade 12. So for you matrix, you can be able to use the power rule. It will help you to work out the correct solution. So it's important for you to understand when you are dealing with differentiation, you need to make sure that you don't have sets. You change them and express in exponential form. And if you've got your variable on the denominator, you need to move it up. When you do that, the exponent changes sign from whatever it was to a negative or a different sign when it goes to the top. And the derivative of a constant is always equal to 0. So thank you very much for that question. We will be back with you after a break with more calculus. Stay with us.